So next is depth first traversal. So today we are going to discuss about depth first traversal. So here the depth first traversal of a graph produces a spanning tree as a final result. So before that we have discussed about breadth first traversal. So there we have used Q data structure, right? So here we are going to perform this traversal with the help of stack data structure. So these are all the steps involved in depth first traversal. Choose any node in the graph, designate it as the search node. So the same like your breadth first traversal. Using the adjacency matrix of the graph, find the node adjacent to the search node that has not been visited. Here we are going to find only one node that is adjacent to the um, vertex that we have chosen. Designate this as the new search node and mark it as visited. Repeat step 2 until repeat step 2 using the new search node. If no node satisfying 2 can be found, return to the previous search node. Backtracking. Okay, continue from there. So when a return to the previous search node is impossible, the search from the originally chosen search node is complete. So if the graph still contains unvisited nodes, choose any node that has not been visited yet and repeat 1 to 4. So the same way what you are going to do is we are going to choose a source node and we have to find the adjacency for the source node. Adjacency for the source node, and we have to choose the adjacent node and insert into the stack data structure. So next is consider this example graph to perform depth first traversal. So this is the graph we have chosen, and select a vertex A, starting vertex, and insert that into the stack. Push A onto the stack data structure. Okay. So now your stack contains A. Then find any adjacent vertex of A, not all the adjacent vertex. So this is the difference between depth first and breadth first traversal. In breadth first traversal, we have to find all the adjacent vertex, and here we have to find only one adjacent vertex of A. So here the adjacent vertex of A is B, right? B, E and D, but we have chosen B. So insert that into the stack. So next we have to find B's adjacent vertex. B's adjacent vertex is what? C, E, F. So we have chosen C now. Then C's adjacent vertex is what? F and E. So now I am choosing E. So E is inserted into the stack. And then E's adjacent vertex is D and F. So we have chosen D now. Okay. Then D's adjacent vertex is what? A and E. Okay. So here there is no new vertex to be visited from D. Right. E is already inserted and A is also visited. So no other go to visit some other node. So what we have to do? We have to backtrack from D. Okay. So we use backtrack mechanism so that we can pop D. Pop D and visit any adjacent vertex of E. So when we backtrack, before D is what? E was inserted, right? So E's adjacent vertexes, C already visited, F is there. So I'm writing F onto the stack. And then visit any adjacent vertex of F. So F's adjacent vertex is what? G, unvisited. So here I'm inserting G. So there is no new vertex to be visited from G, correct? So all nodes are visited. So once we have visited all the nodes from a particular node, we have to backtrack from that node, right? So just backtrack from G to F. G is popped from the stack, and from G, F is there. And the same way, there is no new vertex to be visited from F. There is no new vertex to be visited from F. So so from G to F, so use backtrack, pop F from the stack. Now we are going to pop this F from the stack. And then again from F all nodes are visited, right? Again you have to backtrack from F to G, from F to E. So E again everything is visited. All the nodes are visited, just pop E and then go to E, D. The same way we perform all the operations. So here D is already visited. There is no new vertex to be visited from C. So backtrack C. So I'm just moving to B now. Okay, and then use backtrack the same way. B is also removed from the stack. So from B to A, I'm going to backtrack. So likewise, I am getting an empty stack now. So likewise, the nodes are getting inserted and deleted in this fashion to perform depth first traversal. So from A, I have chosen only one adjacent vertex B, and from B I have chosen C, C to E, E to D, then F, then G. So this is the depth first traversal of the final graph, depth first traversal of the graph. Thank you.